Alright, young chipper, time to go to sleep. Oh, what's that you got there? Oh, that's your great grandfather Rakshit Sharma's medal. He was the best archer at the time.
What? He sounds so cool.
Yeah, he was, son. He was.
Can you tell me the story about him?
Yeah, sure. It all started when I can remember Sensei's teachings. They're all coming back to me.
Thank you so much. Have you ever heard about an archery? Yeah, I have. You want to come arch? Sure. Come to my dojo. Okay. So, you want to learn about archery, huh? Here.
Yes, Sensei.
First you must learn about the history of archery. You must become archery.
Yes, Sensei.
See, archery has a long history. The impacts that arrows have on the society is that it allowed our ancestors to develop the thinking and the basic understanding of drag. They realized that when they fire an arrow, it doesn't go to the intended target. Instead, it goes left or right. And to improve and to create less drag, they figured out that they could put feathers on the back of the arrows called deflection. Armies had to wait for right time to fire the arrows in order to hit the target and hit them fast. This thinking created weaponry such as catapults and mortars, so armies can fire from greater distances and with greater force. And that's how arrows and bow and arrows have affected our society. Fire, child!
Whoa! Oh, why did that happen, Sensei?
Because you're wearing socks on grass. Take these.
All those shoes do, Sensei.
You see, child, the average weight of a male in Canada is 80.3 kilograms. Times that by the gravity, you get F normal, which is 786.94 newtons. And the coefficient of rubber on grass is 0.35, that's mu. And multiply that with the F normal and you get friction static, which is 275. But with nylon, which is what socks are made out of, the coefficient of that is 0.15. So if you take the same F normal and you multiply that by 0.15, you get 118. The bow outputs on average 180 newtons back on the person because of Newton's third law. Every force has an equal and similar reaction. And that's why he fell. Yes, my greatest pupil, Rakshit Sharma, is making so much progress and so much progress. I can see he's going to become great one day. He's going to win a medal for our nation. Sir, time to go up. By the way, the wind resistance is 10 meters a second to the west.
Thank you, good sir.
Rakshit Sharma stepping on the block. Let's see if we can get this. But what is this guy thinking?
I know that my bow will release the arrow at a velocity of 60 meters per second. I also know that the horizontal and the target are both at a height of 1.6 meters and have a distance of 30 meters. As I must raise my bow from the horizontal to hit the bullseye, there is an angle that is created which I must find. Starting off, I know that in projectile motion there is an x and y component. So I must create two equations. The first equation can be made for the x component, using the equation v is equal to d over t. For vx, I can create a triangle knowing that my hypotenuse will be 60. So I can get x by using basic trigonometry and get it equal to 60 cos theta. I also know the distance to be 30 meters and the time is unknown. To rearrange for the unknown, we get half cos theta. Next, we can use the equation d is equal to vt plus half at squared for the y component. To simplify, the distance is 0 as both the horizontal and the target are at the same height, and I solve for Vy using the same trigonometric method, being 60 sine theta. Acceleration is negative 9.8, but by multiplying it by a half, we get negative 4.9. In this equation, time is also unknown, so we can create both equations. We can equate both equations by substituting t from the first equation. From here, we get 60 sine theta multiplied by 1 over 2 cos theta minus 4.9 1 over 2 cos theta squared. So by multiplying it all out, we get 30 tan theta minus 1.225 over cos squared theta. Looking at the next line, we know that 1 over cos squared theta is equal to secant theta. And so I simplified it by making the equation 30 tan theta minus 1.225 secant theta. And to further simplify, looking at the next line in the equation, we know that secant is equal to 1 plus tan squared theta. So multiplying everything out, we find that the equation is actually in the form of standard form, where it is like where tan theta is kind of like x, and so the equation is ax squared plus bx plus minus plus c. And so to solve for x, which is tan theta, we know that we can use the quadratic formula, which is um, tan theta equal to negative b plus minus the square root of b squared minus 4ac all over 2a. And so when we substitute b, a, and c in the equation, we find that tan theta is equal to two values, one being 0.0409 or 24.4469. And so to solve for theta, we just take the tan inverse of these two equations and we get tan equal to theta equal to approximately 2 degrees, or it being equal to 88 degrees. And taking the simpler angle, I know that I can raise my bow at an angle of only 2 degrees and I will be able to hit the bullseye. Well, I know that the wind component is going 10 meters per second, and I know that my bow can release my arrow at 60 meters per second. So if I was to leave my bow at the horizontal and release the arrow, the wind component would actually move my arrow towards the west, which is something I do not want. So to compensate for this, I know that I must move my bow towards the east. And so this angle is actually north theta east. And to solve for this, I create a triangle in my head, and I know that the x component is 10 meters per second, and that the hypotenuse, the net, is 60 meters per second. So using basic trigonometry, I know that sine theta is equal to opposite over hypotenuse. So this, in this case, being 10 over 60. And to solve for theta, it would just be sine inverse of 10 over 60. And so I get theta to be approximately 10 degrees. And now I know that to hit the bullseye, I will have to go from north 10 degrees towards the east.
Rakshit shoots, and he hits it on the bullseye. Oh my god. Now the rival comes up. If he hits the bullseye, he wins. No, he lost. He's fluffed it. Oh my god. Rakshit's won. He's won the gold medal for Canada.
Hey man, don't cry. I saw your performance out there. You're actually a really good guy, and I feel like you have a lot of potential. You accounted for every factor except for one thing.
So you see, son, what you forgot to account for is momentum. And momentum is represented by the equation of P is equal to mass times velocity. And so you see the velocity is for my bow is actually 60 meters per second. And the mass, I'm using regular arrows, and the average mass for those are 18 grams or 0.018 kilograms. And so calculating this, we can find the average momentum, which is 1.08 kilogram meters per second. And so the new momentum for you, on the other hand, if we take the same proportion of the average momentum being 1.08, we can equate this to the weight of your arrow, which is 0.023 kilograms, and rearrange to solve for the velocity, which would then equal 46.9565 meters per second. Now, so this is your new net velocity at which your bow is launching the arrow. So similarly, when using projectile motion, we can substitute this to create two equations. For the first equation, it would be Vx is equal to d over t. Using trigonometry, we know that Vx would be equal to 46.9565 cos theta, which is then equal to 30 over t. Rearrange it, we would get t is equal to 30 over 46.9565 cos theta. And for the second equation, it would be the same scenario where distance is 0, and this is equal to 46.9565 sine theta for our Vy, multiplied by time minus 4.9 t squared. So again, as both equations have t as the unknown, we substitute equation 1 into equation 2, and as we multiply it out, we see that it's again simplifies into standard form, where we have our a value, our b value, and our c value. We solve for tan theta by using the quadratic formula, and we get tan theta equal to two values, one being 0.0670 or the other one being 14.9330. And when we solve for theta, we just take the tan inverse of these two values, and we get it to be approximately 4 degrees or 86 degrees. So now, to just show you a visual as to how this works out, the blue lines represent my weight, the average weight of my arrow being the 0.018 kilograms, and the red represents your weighted arrow being the 0.023 kilograms. So you see, when I take my lowest angle, mine is 2 degrees, and this makes sense as mine is not that weighted. So what will happen is mine will travel perfectly to the bullseye, whereas because yours is weighted, your degree must be higher than mine, as the mass will then bring down, as the mass of the arrow will further bring down your arrow, and it will miss the target. So when you make the angle higher, what's actually happening is that your arrow is able to travel through the air and hit the bullseye with that higher angle. In the second scenario, if we took the higher angle, you can see that my arrow angle is higher, and this is because the velocity of my arrow is much higher than yours, meaning that it will have to travel higher to make to reach a higher maximum and then fall back down to hit the bullseye. Whereas yours, because yours is weighted and has less velocity, it will reach a lower maximum and fall back down to hit the bullseye. And see, this is the mistake that you made in your calculations.
And so you see, that's when Raksha Sharma took in his rival Indi Pindi as his new disciple, and the rest is history. Wow, it's getting very late. I think you should go to sleep now, son.
Wow, Gramps is so cool.
I know, son, I know. Good night.
Good night, Dad. I'm gonna search up Raksha Sharma on YouTube. I wanna see some clips of him winning. Woo! We're gonna have this very special guest, Olympic Canada gold medalist, best archer in the nation, in the world right now. He's gonna kick my butt, he's gonna kick everybody's butt. Welcome, Raksha Sharma! Ram se, Ram se. Come on.
How are you, sir?
Good.
Good.
So, it's a pleasure having you here, Rakshit.
Yes.
I know you're a busy guy to get a hold of, huh?
Yeah.
Yeah, working around the indie kind of guy.
Yeah.
How's he coming along?
He's very good. He's made a lot of progress, and I'm so glad that he asked me to become my disciple.
So, we've brought in karate masters. I'm karate master myself, and I can break a cinder block. Let's see if you can break it with your bow.
All right, let's see what happens.
Are you ready, Rakshit Sharma?
You but I am, sir. But you see, I already know what's gonna happen.
Oh yeah, what's the outcome?
Well, you see, the arrow's actually gonna bounce off the cinder block and it won't break it.
All right, let's see about that. Rakshit, you said you knew the outcome, and you were right about the outcome. How come?
Well, you see, in archery, there's a lot of physics involved. The two main concepts are kinematics and forces. And in this case scenario, it was mainly forces that were involved when I shot the arrow towards the cinder block. And so there's two principles that are involved in forces for this one. The two concepts are the amount of force that is that the actual bow is applying onto the arrow while it's firing. And the second is taking the concept of Newton's third law of motion, which is every force that is acting upon an object has an equal and opposite reaction. So I knew that the arrow would not have enough force to go against the force that is being repelled by the cinder block. And I can show you this right now.
So you see, this is another projectile motion question, but in this case scenario, we are taking force into consideration. And as my bow is lined up on the horizontal and my arrow is being shot from the horizontal to hit the cinder block, we would first have to account for acceleration at which the arrow is just initially launched. So I know that when it is launched, my bow releases the arrow at a speed of 60 meters per second. So that would be equal to my VFX. I know my VIX is equal to 0 as the arrow is not moving initially. Acceleration is unknown, and I know that my time is 0.004 seconds as the average rate, average time that it takes for a bow to launch an arrow is 4 seconds. So taking this all into consideration, we can rearrange this equation to find that acceleration is equal to 15,000 meters per second squared. And now, seeing the diagram that I have created as the triangle, we see that F net, there's two components there, the Fx and the Fy. So to solve for Fx, we know that this is equal to mass times acceleration, and we know that mass of the arrow is of my arrow is 0.018 kilograms, and that the acceleration is 15,000 meters per second squared. So multiplying these two, we get 270 newtons of force on the x component. For the y component, we know that Fy will just be equal to Fg, which is the force of gravity, as it is just going down going down towards the cinder block and is lined up on the horizontal, so there is no distance involved on the y. So we know that it would be mass times gravity, and this is now 0.018 multiplied by 9.8, and we get Fy to be equal to 0.1764 newtons. To now find the F net, so the force total that the arrow is giving off, we can use the equation as shown, and as we simplify it, we find that the arrow gives off 270.0000576 newtons, or approximately 270 newtons. So now that we have the force net of the arrow, we must now calculate the force that the cinder block can take before it can break. So we can use the formula force of the block required in pounds, which is equal to perimeter in inches multiplied by thickness in inches multiplied by psi, which is the strength of the material in pounds per square inch. So we found the perimeter of the cinder block to be 41 centimeters, and we know the thickness of the block to be 2.5 centimeters. And to now convert these into inches, we must divide the both values by 2.54. And by knowing the PSI, by researching, the average PSI of the cinder block is 3000. So when we take all of these values together, we get the equation to be 16.1417 multiplied by 0.984252 multiplied by 3000, and we get 47,807.78 pounds. And then we can convert these pounds into newtons, which is 212,659.6 newtons. So it takes that many newtons to break the cinder block, whereas the arrow gives nowhere near as amount as force onto the cinder block. Thus, Newton's third law of motion comes into play, where every action has an opposite and equal reaction. So when the arrow hits the cinder block, it's applying approximately 207 newtons onto the cinder block, and the cinder block is applying that much force back onto the arrow, and thus it bounces off the cinder block.
Wow, my great grandfather's so cool. I want to be just like him now. I want to become an archer.
Sir, your time's up. Just to let you know, the wind speed outside is 10 meters per second west.
Alright.